Today, we have one major goal, and that is to look at the three main types of plate boundaries. Identifying them on the map is key. The other main thing you need to know about each type of boundary is whether or not it gets volcanoes and big earthquakes or small earthquakes. Really, plate tectonics is just a giant recycling machine. And so this is where the new rock is created, usually at the ocean floor. In fact, there is only one diverging boundary that is above water. So we have a process going on here called seafloor spreading. This was kind of discovered in the 1950s after World War II. A sea captain who was a geologist in his real life was a captain of a ship in the war, and he ran his bathymeter, which mapped the ocean floor, and he discovered this giant mountain range under the Atlantic Ocean. Before that, we actually thought the oceans were just like big bowls and they were flat on the bottom. So huge discovery. The oceans aren't at all flat. And we realized that as you move away from the middle, that the rocks get older and the rocks are young right in the center where it's split open. Okay, so that's called a rift valley. Rift means tear, and the valley is the opening that is created. Notice that on each side of the diverging boundary, the rocks are kind of raised. We call that a ridge. Are there volcanoes here or not? Well, technically, this is considered a volcano. It's called a rift eruption, but it's not the kind of volcano we normally think of. So we don't think of there as being big volcanoes on diverging boundaries. Are there earthquakes? Yes. Anytime the crust moves like this, that's an earthquake. So there are lots and lots and lots of earthquakes at diverging boundaries, but they're small. They're usually not the kind of earthquakes that present a big problem for us. So earthquakes, yes, but small. Volcanoes, yes, but also relatively safe. Diverging boundaries are not particularly dangerous. You can see this crack that runs all the way down the Atlantic Ocean. We actually call it the Mid-Atlantic Ridge. And you can see it's pretty much underwater the whole way. There is something weird that happens way up north though. You see that island? That's Iceland. And this crack, it's hard to see from this map, but the crack actually goes right through Iceland. And that is the only place on land where we have a diverging boundary on Earth. Literally, you can go to Iceland and you can put 1 foot on the North American plate and 1 foot on the Eurasian plate and take a cheesy tourist photo. You see the factory behind it, and it looks like there's pollution coming up out into the air. That's not pollution. This is what we call geothermal energy, and we'll study that second semester. It's considered renewable and relatively clean, unlike things like coal and fossil fuels. So they're able to catch the heat coming out of the ground, out of the crack, and turn it into usable electricity. What you see coming out of the smokestacks is water. That's just steam. So it's, we'll talk about the pros and cons of geothermal next semester, but I wanted to introduce that today. Converging is the opposite of diverging. The rocks the lithospheric plates are coming together. Now there's actually 3 kinds of converging boundaries. We're not going to get too technical, but you see 2 of them here. The top one, we have an ocean plate hitting a continent plate. An example of this would be I'm going to call it the Pacific plate. It's really the Nazca plate, but it's crashing into South America, and it pushes those mountains up that you see there. Those mountains right on the coast. And it's a skinny little mountain range, but that's the Andes Mountains. And they are highly volcanic and highly deadly. They erupt violently for sure. And then on the bottom one, we've got really the same situation. We've got, in this time though, we've got an ocean plate that's crashing into another ocean plate. There's a gap between the continent and the ocean crust. And so what happens here, we still get the volcanoes. They just don't form on the continent. Instead, they form a little bit off the continent. Now this is really important. They call this an island arc. An example of it would be Japan. Japan is off the coast of mainland China, but it is created because of a boundary like this. And that extends further south into the Philippines, Indonesia, all of those islands that wrap around the Ring of Fire are this kind of boundary. Another thing that forms at these boundaries, what happens is whichever plate is more dense gets pulled down underneath and melted. And that's what's making the pressure for the volcanoes. As it gets pulled down, that's called subduction. Subduction is pulling underneath. But where they come together, it makes like a V shape. And we call that a trench. So trenches are the deepest spots on Earth. They occur, almost all of them occur around the Ring of Fire. And so you've probably heard of the Marianas Trench. That's south of Japan. And it's where the Pacific Plate is diving deep underneath. I just said this is the Ring of Fire. So it is the biggest, baddest volcanoes, and it is the biggest, baddest earthquakes. The deeper the trench, usually the bigger the quake. So these are the deadly ones. In fact, most of the world's active volcanoes are converging and Ring of Fire. 80% of the world's eruptions are Ring of Fire or subduction. So there's an ocean floor map of the Pacific, and it's pretty dotted, right? We're going to come back to this later in the week. This line right here, that's Hawaii. And Hawaii is really weird because it's in the middle of the plate. We call that a hot spot instead. But you can see it connects all the way to the trench up by Russia. And so here is the Marianas Trench, the deepest spot in the world. And right there is where we had that giant earthquake, which had the huge tsunami and killed hundreds of thousands of people. Over here, you see the Pacific diving underneath North America, and it's created all these mountains and the volcanoes that we get in Washington. It's called the Cascade Range. Once again, that's subduction, diving underneath. All of the little volcanic island arc off of Alaska, that's converging. And here's what I talked about before, the Andes Mountains run down the coast of South America. So all of this converging boundary makes either volcanoes on the land or volcanoes in an island arc, along with trenches. Everything you see is subduction. Now, the third type of converging boundary is called, they simplify it, it's two continents hitting each other. So we could call it a continent-continent converging, but scientists are lazy and they don't want to write all that out. So they just call it a collision boundary because you got two continents colliding. Boom, it's a big accident. Two semi-trucks hitting each other. And India is the perfect example. I'm going to show you an animation here. It went flying across the Indian Ocean and it slammed into the Eurasian continent. And the only place for the rock to go, there's no subduction here. The only place for it to go was up. And actually, it's still colliding today. You've probably heard of Pangaea. Pangaea was a supercontinent where all of these tectonic plates were connected together. And this was about 250 million years ago. I'm going to run an animation here. And there's two things I want you to notice. I want you to see how North America splits apart and South America splits from Africa. That is where the Atlantic Ocean forms. And remember, that's called seafloor spreading. And then eventually it's down here by Antarctica. Most people don't realize that. But India used to be connected to Antarctica. And so India is going to take off really fast and shoot across the ocean, and you'll see it kind of crinkle up as it hits Eurasia. Okay, here we go. So this is from the time of the dinosaurs. The dinosaurs were alive, and it'll go all the way up through their death. The continents were mostly connected in the early days of the dinosaurs. And we're getting close to when the dinosaurs died off, and by then the continents had separated. There goes India. Boom, 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 it's sliding. And then it goes really fast, and there's the crinkle as it smashes into Eurasia. Our third type of boundary is called a transform boundary, or a simpler name for it is a sliding boundary. And at this boundary, the plates are not moving together or apart. They are simply sliding past each other. We typically do not get volcanoes at these boundaries. No volcanoes. However, we can get big earthquakes when the plates lock together and then release their energy. What you're looking at on the right is called the San Andreas Fault. It's in California. It's the big one. And you can literally see the ground is basically torn apart. We do worry about places where the tension starts to build.